Alright, hey. You guys have a quiz. I don't know when. I'm thinking Thursday still. And we'll see if maybe it gets pushed back to Friday. But again, plan on Thursday. And let's go over this stuff. You're definitely going to get questions like this on the quiz where you'll see a big diagram and you just have to name the parts. On your check for understanding, I think I asked for a radius. You had to find a radius yourself and name it. So you might have said AC and then put a hat on it, right? This review sheet though, I'm naming parts. You see FG I'm asking for. So you see that thing right there. That's a chord, so you find chord, you mark it C, okay? I think the way the quiz is going to be is more like this, but it's not just going to be matching. You're not going to have this. You're going to have to name the thing. So where it says FG, the arc, you'll have to actually write out minor arc rather than just matching it to a letter. Although good news, you don't have to pull the word out of your brain necessarily. You are going to have a word bank. And so in that word bank, you'll see radius, diameter, chord, secant, tangent, blah, blah, blah. But it won't be as easy as just sort of matching. I still think it'll be fine. So, you know, whatever. We'll see. All right, so what's AC? AC is this guy. So you'd read through the word bank. Hopefully you already know what that is. It's a radius. So you'll say radius. Okay. Angle FGC. From F to G to C, since our vertex is on the circle. That's an inscribed angle. And then you got ED with a line hat on top of it. So if I had said ED, the segment, you'd say chord. But since this is ED, the line, that's a secant. Angle CAB, if we go from C to A to B, then we see that's an angle whose vertex is at the center, so that's a central angle. FGC, all right. When you see an arc with 3 letters in its name, it's definitely not a minor arc. Minor arcs only ever have 2 letters in their name, like FG. But FGC could still be a semicircle. So where does F start? Here? Where does it end? C? Over here? And since we've got the 3 letters telling us we start at F, but we have to go through G, then we know we're coming the long way around. And we can see that's more than half of the circle. So that's definitely a major arc. On the other hand, GBC. G is starting here. We pass through B and we stop at C. So since GC is a diameter, we know that GBC is exactly half of the circle. That means that's a semicircle, not a major arc. Okay, now you've got line JB. Line JB is this guy. And since that line hits the circle only once, that's a tangent. And then lastly, GC, segment GC. Ah, we already said that one. Segment GC is this guy here. That goes all the way across the circle, passes through the center. That's a diameter. Okay, so just make sure you know your vocabulary. Make sure you know it well enough that you can pull the right word from a word bank. I think that's how this is going to be set up, okay? But that's it. Let's do some of these problems now where you got to know your theorems. And right away, I'm kind of hitting you with something I haven't taught you. So let's do it without using the rule that I haven't taught you yet. And then I'll give you kind of a shortcut rule. But looking at this, I need the measure of arc AB. AB is this guy. And I might not be able to find that yet. Maybe I got to find some more stuff first. I kind of don't. You should see this inscribed angle right here. The one whose vertex is at D. Oh geez, that was rough. See that 88-degree angle? You know that inscribed angles are half of the arc they cut. So that means the arc that goes from A all the way to C would be 88 times 2. So 176. But then you know that BC is 64. So wouldn't AB be the full arc AC, the 176, minus the 64? And then what is that? I don't know what that is. I'll just get a calculator so I don't mess it up. But 176 take away 64 is 112. So that red guy's 112. And you definitely had all the theorems you needed to figure that out. Okay, now what? They want the measure of AD. So AD is this blue arc down here. And hopefully by now you're noticing that's the only arc left, because we already know that this piece is 92. We know the red piece we just found to be 112. And purple, I guess? This purple guy up here is 64. So of course the whole circle has to be 360. So you know, if we want to just call this guy down here X, there's no other X anywhere, right? So mark that unknown as X. So you take the X, you take the 112 from the red, you take the 64 from the purple, you take the 92 from the orange piece, and you know that all four of those arcs added together would make the whole circle, which is 360. So you can write yourself an equation and solve it. So let's take the 112 plus 64 plus 92, and that's 268. Made a bit of a mistake there. Obviously I should be saying X plus 268. Now you're just going to subtract 268 from both sides. This will cancel and you'll get X equals, I want to say, what, 92? So there, we found a second arc. 92. And all this maybe wants to be blue. Yeah, sure, good enough. Alright, so what are they asking for now? They want the measure of angle ABC. How do I find that? And what color do I make it? Red, orange, yellow, green, blue, purple? And we literally used all the colors except for yellow, but yellow doesn't show up. Whatever. ABC. Yeah, ABC is just this inscribed angle here. And now that we know that blue guy is 92, then we should be able to see that the angle they're asking us to find, this guy, well, that inscribed angle cuts this big major arc that's formed from the blue and the orange together. Those are both 92. So that's a big coincidence. I don't know if you guys, nobody would have looked at this and thought that those had to be congruent, I don't think. It's a coincidence that they both came out to 92. So anyway, what's that big arc going to be if you add the 92s? It would be 184, right? Then of course this inscribed angle would be half of that. So it's 92. So that's not exactly a coincidence. Obviously if you do 92 plus 92 and then chop it in half, you're back to having 92. But it's a coincidence that those two arcs are the same. So that's a little bit strange that this came out to 92. But hopefully you understand why. All right, let me now give you another little rule that's kind of buried in here. Can I just duplicate this whole page? Is that how that works? Yep, it is. All right, so here's a rule that may or may not be helpful. Anytime you've got, oh, that's weird. Anytime you have a circle, and inside of that circle is a quadrilateral. So if you drew a line, a line, a line, a line, so that you had a quadrilateral and all of its vertices were on the circle, then there's another little rule buried here that opposite angles will always be supplementary. So if I told you this angle here was 120, without having to do any math, you would know that the opposite angle was 60. because they have to add up to 180. That's a rule. You can take that to the bank. If I told you that this angle right here was 82, then you'd know this other guy had to be 98. And that's automatic. That's a new rule. You guys, what do we got in our packet? We have 6 rules. You can write that down as rule number 7 if you want to. That opposite angles of quadrilaterals inside of circles, those opposite angles are always congruent. So how would that have helped us here? It would have helped us here because we would have known, all right, this guy's 88, so this guy's automatically 92. Remember, they asked us for that. And we did all this rigmarole. But we actually know it's 92 pretty much immediately if we know that rule about opposite angles being congruent. So then we could do the 64 and the 92, add those guys together, and you get 156. So half of 156 says that this angle here would be 78. Did we ever even know that? I don't think we ever cared. It wasn't actually important to the question. But if it was, you'd know that that's 78. And then you could use that 78 to say that this guy over here is 102. Because they have to be supplementary. Does that help? I don't know if it does. But anyway, we got all the answers using the other theorems that we learned in class. It's never bad news to have another way to do a problem. Okay, so I'm always going to share with you another way to do the problem that may or may not be helpful. Honestly, maybe it comes up, maybe it doesn't, but if it helps somebody, then good. Moving on, click. Let's do 12. So this is another problem that we could do 2 ways. What do we know? That 62 is trying to be this arc. I don't know if you could tell that or not, but the 62 is this arc. So that makes solving for y pretty darned easy because angle y is a central angle, and central angles are equal to the arcs that they cut. So y is automatically 62. No math to show. You just know it's the same. Now, probably the fastest way to solve for x would be to remember that we had a rule that says that the radius drawn to the point of tangency of a tangent line is perpendicular to the tangent line. So this line is a tangent line, right? So that blue line's a tangent line. This green radius therefore has to be perpendicular to it. So you know you've got a right angle here. So you know that this whole triangle is a right triangle. And we just said that y is 62. So if you've got a right triangle, you know that's your right angle. You know that this guy's 62. Then you know that all the angles have to add up to 180, right? So we could just do 180 minus the 90 minus the 62. That, of course, is just going to be 90 minus the 62. And 90 minus 62 is 28. So we can figure out that x is 28 that way. And then we're done. And that's a perfectly valid way to do this problem. But, just cause, let me duplicate this page. And we'll do it again. Did it duplicate? It did. Alright, so another way to do this problem then. I can make these way bigger. Way bigger. They told us that this arc was 62. They're also calling this circle... No, they're not calling it anything. So maybe this isn't obvious, but we're taking this point to be our center. It doesn't say anywhere that that point is our center necessarily, but it is supposed to be. So that means that this arc here is actually a semicircle because this is a diameter. So we can definitely say that this arc, the one I'm marking in green, let's make that thicker. This arc that I'm marking in green is 180 minus the 62. So it's got to be what? 118. Alright, so now we could use one of our other rules. The one that talks about angles formed by secants and chords that intersect outside of a triangle. So we've got this angle x. Isn't angle x supposed to be the difference between the 118 and the 62 divided by 2? We've got that rule that says angle x is definitely going to be half of the arc minus the arc. So at this point we could grab the 118. We could grab the 62. and just do half of their difference. I don't feel like doing math tonight. 56. There, I did it. It's 56. But for some reason my brain doesn't feel so good, so I'm going to double check. 118 minus 62. 56. Alright, 56. And half of 56 is 28. And guess what? Didn't I already say it was 28 previously? So I got 28 just by knowing this triangle had to be a right triangle, because radii and tangent lines are perpendicular. That's one of our theorems. But we have that other theorem that says angles formed like this on the outside of circles are half of the difference of the arcs. So there's two ways to do this problem. Either way is fine with me. There's pretty much always going to be more than one way to do these problems. So as long as you guys use a method that's a legal method, then you're fine. Alright, let's do this problem. Now this time there's a rule that I think you really do just have to know, and I never told it to you. I'm not sure if there's any other way to do this problem, but let's find out. So it says APT is 54. APT being that central angle. So it's probably obvious to you that if the central angle is 54, then the arc that it cuts is 54 as well. So what do they want? They do want that arc. That arc's just going to be 54. No math to show for that. You just know they're equal. Then they want MH. And so MH is just this random arc over here that I guess will be blue. Not so good at tracing. Then there's this other arc over here called HT. There's this other arc over here called MA. And I got a suspicion that it's probably something you guys all assumed, was that because all of these chords are marked as being congruent, it's probably true that the arcs that they cut are congruent. You guys buy that? That if the chord MA and the chord MH and the chord HT are congruent chords, then arc MA, arc MH, and arc HT are congruent. And that's true. That's a rule that I never bothered to have you guys write down, but it's 100% true that in any circle, if you've got a chord and a second chord and those chords are congruent, then the arcs they cut are congruent. This was horribly drawn. But if I told you those guys were congruent and I told you that this was, I don't know, 105 degrees, then you would definitely know that this other arc over here, if I said solve for x, you'd go, well, x is 105. Because congruent chords are always going to slice off congruent arcs. Alright, so what does that mean to us? That means that if they want us to find MH, if we call that x, then they're all x. That guy's x as well. So you probably see where I'm going with this. We know that to solve for x, you would just do 360 minus the 54, and then divide that equally by 3 and get the 3 pieces. So technically what you're saying is the x, the x, the x, and the 54, they make a full circle, so of course they all have to add up to 360. So the 3x's make, well, 3x plus 54 equals 360. So that's a 3x. If you subtract the 54, you get 306. Then you finally divide by 3 and you get 102. So each of these arcs is 102. Alright, and then they want HTM. THM? Measure of angle. THM. So this angle here. Okay, so looking at that angle, we see it's an inscribed angle. And you guys can see that for me it cuts the orange and the pink together. And we just said that orange is going to be 102. Because all of these arcs are 102. The blue, the orange, and the green at least are 102. So that means the guy up here that's getting cut by the angle that we want is this whole thing in lavender. It's the 102 and the 54 together. So that's 156. So the angle down here must be half of 156, which is 78. Sure, there you go. There's those. Last problem on the sheet. I think is this one. That's it. So there's nothing super tricky here. One of the big tricks here, I guess, is, why am I bothering to tell you that that this chord is parallel to this radius? Well, I'm probably telling you because once you know that, you'll be able to say that this angle is the same as this angle, because those are alternate interior angles. We're using the rules of parallel lines again from a while ago. So that may come in handy. Another thing that's important here that you'd have to notice is AT. That's a diameter, because we know that point D is the center. So that means this whole thing, AFT, is a semicircle. So that would be 180, right? And then notice that angle ANT is cutting that semicircle. So this angle here must be half of that semicircle. So that angle that looks like a right angle, it is a right angle. We can actually prove that it's a right angle. So I think you have to know those two things sort of right off the bat. If you don't know them, you might be in a bit of trouble. So I'm just going to explain that right away. This angle here is definitely going to be the same as this angle here. And this angle is definitely going to be 90 degrees. Knowing those two things should help us a lot. All right, what else do we know? Well, they gave us that the measure of, I assume they're saying arc NT, is 118. So how does that help us? Is that all we got? Yes. So they now want the measure of angle ANT. ANT is the 90 degree angle that we already talked about. So there's that. Now they want ATN. That's this angle here. And that is an inscribed angle that cuts arc AN. And we just said that AFT was a semicircle. Well, ANT is also a semicircle. So you know that AN will just be 180 minus the 118. So 180 minus 118 leaves us with 62. So that means the inscribed angle down here is half of that, so it's 31. And finally, they want AF. AF is this arc over here. That green's a little dark for my taste. Okay, so how does that help? Well, you can see we could find the green if we knew this central angle. And I just told you a minute ago that central angle is going to be congruent to this inscribed angle. And that inscribed angle cuts our lavender colored arc. So you know that inscribed angle is half of the 118. So it's 59. But then if that inscribed angle is 59, then the central angle is 59 because they have to be congruent because they're alternate interiors. That tells me that this arc is 59. Because central angles are equal to the arcs they cut. So there's a handful of problems demonstrating how to use our handful of theorems. And I think tomorrow the plan is for me to give you some more problems to practice with. Maybe I'll just pull them from Delta Math. Maybe I'll make an actual worksheet. I'm not sure. But, you've got this video to watch now going over these practice problems. You'll have a second batch of practice problems. And you've got the homework, too, from the actual packet. Don't forget. So hopefully by Thursday you're fine to take a quiz. Anyway, see you later.